Hi everyone, my name is Zach Prater, and we have Gabriel Burrows. He's going to be giving the technical workshop over Cartesi. This technical workshop is to kind of educate everybody about our tech for ETH Denver. So thank you all for making it. Sorry if it's early, but let's jump into the workshop.
Hey guys, let me just set up here.
I was just maybe just 2-3 minutes more so that more people can join in.
Yeah, that's
Okay.
fine. So where's everybody from? I'm from the United States, so it's a little early, but I'm excited for ETH Denver.
Just keep it here.
ETH Denver is actually going to be a lot of fun for the entire Cartesi team. A lot of us are flying out, and a lot
Next
of people
week.
attending the event. Yeah, it's next week.
So excited, man. So
Decent
excited.
amount of people attending ETH Denver too. Isn't it the oldest cryptocurrency conference?
I think yeah. One of them at least. One of the
Yeah.
OGs.
Well, good for them. I'm curious if Vitalik is going to show up in a costume like he did last year. He wore the Buffington costume just so that no one annoyed him. A lot of people on the call. Thank everyone for making it.
Yeah.
Hello, Crypto Gambler. It's good to see you.
Great to be here again. Thanks, everyone. Excited for this session.
How early is it for you?
It's 1 o'clock in the afternoon in good old sunny Amsterdam.
Oh, that's not bad at all.
How about you guys?
For me, it's 6 a.m.
Yeah, so early, man. 9 a.m. over here.
I like it. The first thing you think of when you wake up is Cartesi. That's the spirit.
Yeah.
The first thing when he wake up is like, oh, what did Gabriel do?
I'm excited to do this because I'm the host, but Gabriel's got all the technical stuff. So
No, Lena's doing it too, man. Lena's
both
doing
of
the
them.
good stuff.
Even easier for me.
Yep. You know what, Zach? It seems like we have students from São Paulo over here. Hi there, Victor.
Hey there.
Ooh. Hi, Victor. It's nice to see you tuning in from Sao Paulo.
Oh yeah, it's nice to be here too.
Yeah, we are using the room audio, so we're having some problems with the echoes. I don't know.
That's pretty cool. So y'all are tuning in together?
Yeah, we're here.
Probably I'll ask for a participation of you guys in the room because I have a eco presentation as well.
So, Gabriel, where is this session anyways? Are you guys in a room with a bunch of coders, or what's the setup like? Maybe describe it for us.
Oh yeah, all remote. Everybody is in the on their own houses, and we're just setting up from here. I'll be just explaining a little bit overall the technical side, like what you need to know in a very high level. And then Lino is gonna be running some code, changing some stuff, playing around a little bit with the framework, so you guys have a sense of how everything comes together.
Amazing. Super excited. Thanks, guys.
Yeah, I guess maybe we can start, Gabriel. It's over 5 minutes. So
Okay, sure thing. So, like I was saying, this first bit of the session is gonna be how it works in a very high level. I don't have the time to be super technical. I'll be talking about concepts here, and I hope things make sense for you guys. But we're gonna have a Q&A at the very end, and if you still have questions, you can ask us. And also, the Discord is open, right? Like we can always answer your questions on the channels. So starting off, what are rollups? Many have probably have heard of it, have heard of zero knowledge rollups, optimistic rollups, but I think we need to take a little step back. It first starts with the trilemma of blockchain. You need to optimize for two of the three: decentralization, security, and scalability. You see that happening with Bitcoin, with Ethereum, and with other networks. You generally see they are compromising on either decentralization or security in order to gain scalability, and that is something that you cannot get around, really, not so much. And what rollups do, they focus on scalability, and they try to maintain the same level of security and strive to maintain as well the decentralization. It's still something in the works, I guess, within the community. The decentralization is quite not there, but it's technically possible. So focusing on scalability, the idea is to increase the throughput of transactions, so we can have many more transactions. Also, the capacity of any of the transactions. So how much you can process there. Like nowadays, if you think about Bitcoin, they're mostly just balance exchange, right? And if you think about Ethereum, they're a very, very simple computer that where you cannot do a lot of complex things, and that limits a lot on what DApps can do. And what one of the things that people are trying to expand on is exactly that, to be closer to the realities of our phones and computers, but inside the blockchain. And the end result and the objective really is to reduce the cost of running dApps and having more um, technological power, I guess. And how do we do that? We do that optimistically. We do optimistic rollups. And how does that work in essence? So you have the main blockchain, and within one of the blocks, you send a transaction, basically stating the initial state of an off-chain machine. So if you think about Optimism, Arbitrum, all the EVM-based optimistic rollups, basically they have an EVM as well off-chain, and they have a merkleization of the state of the machine, and they state that in the very first transaction where they're starting the rollup. Then they go on processing lots of transactions, and within a set of time, generally 7 days, they state the end result of those 7 days. And that is the beginning of the news cycle. And that's mostly how rollups go. It's just about stating the states of what happened outside of the chain instead of really reprocessing all the stuff again. So, but Cartesi does it a little bit different. So if you think about how the main rollups that we have out there work, they are basically a copy of Ethereum in the sense that you send an application there and it interacts with all the other applications like they were in Ethereum. You can basically abstract the idea that you are even in the L2. But that will lead to competition between among the applications, as it had happened in the Ethereum network before. So if you think about it, in the history of Ethereum, at some point, at the early beginning, you had games trying to be created inside Ethereum, and they were striving to be successful. But at some point, they all were evicted from the chain because the file was so big and people could pay more for transactions. It made more sense for them to pay more. And what happened is all the games were evicted from Ethereum. So instead of having one network for all applications to interact together, we have app chains. So when you look at Ethereum or any of these chains, the more computers you add to it, the more secure and possibly decentralized the network is. But it does not mean that the network became more capable, that it became more powerful. There's no speed increase on that. However, when you look at app chains, you have segregated networks that work in tandem to each other and they do not compete for resources. So maybe a computer here in DApp is a validator for DApp as well, but they are not sharing resources really because you still have all the other computers making securing the network for the other dApps. So for DApp and DApp does not mean anything that DApp is very, very successful. It's not gonna impact on the daily lives of the users of DApp and DApp. And then when you look at these networks as well, basically you have a improved version, a more powerful EVM. But instead of doing that, Cartesi focused on doing a RISC-V emulator. So RISC-V is a platform processor. It's just like the ones on your phone or your computer, but it's an open hardware architecture. So it's the open source version for hardware. And this is good because it's a complete machine. And with that, you can have operational system, and especially a traditional operational system on it. So we put Linux on it, and now it means that you have a very powerful CPU. You can have all the stuff that operational systems give you, like resource management, even simple things that you take for granted, like files. And that also means that you can run any toolset there. So you can have a database instead of writing your own crazy logic to manage data. You can do SQL, for instance, and use any language that you're already used to. You don't need to necessarily learn Solidity or any weird version of Rust or Python specific to a chain. Like whatever runs on your computer, it can probably run over here. The only thing that you need to be mindful of is you don't have access to internet, still blockchain guys, and of course you don't have access to GPU over here. And what if there is a fraud? Like, how do you actually make this secure? So there's this concept called fraud proof. So if any of the validators, or if there is a if it is an open network, any of the players of the network see there is a fraud, something wrong going on, you can actually pick up the state transition where the problem happened, send it to the Ethereum chain that is making that there is the security guarantee of the rollups, and basically state, hey, here's a problem, here's the state transition where the problem happened, judge whether or not I'm right, and probably you'll be right, so you'll be slashing whoever made the mistake of the transaction that you're asking the judging to figure out the problem. And then we go to the actual overview of how things work. Basically, you're still gonna have your front end sets of systems. Here, I just have a browser. Supposing it's a website. I'm sorry, guys. 1 second. My voice is cracking up. So here we have a browser, a site of sorts, connecting to Ethereum chain and also the Cartesi Rollups framework. you're still gonna have your JSON RPC connection to the Ethereum node, and then you have two new connections over here to get information from the Cartesi node, and that's the outside view. From within the Cartesi machine, you're gonna have this API over here, the HTTP dispatcher on this image, to communicate with the outside world, really to communicate with the layer one that you deploy to. And that looks like this. So from the inside the machine, you have these types of calls that you can do to the API that I was talking about. There is a documentation deeply explaining what it means, each of these. But basically, you have to understand that this is still a smart contract. So it means that you have state transitioning functions, and then you have reading, read-only transactions, so to speak, not transactions, read-only API calls to the machine. So for people who are familiarized with Ethereum, it's basically what Ethereum call does. So whenever you're checking your balance on your ERC20, you call balance of. Basically, you're waking up the EVM machine to check what is your balance at a specific token. This is the equivalent of it. So you have these two types of requests that your backend can receive. One is the state transitioning one, and the second one is the inspect state, like we call it. And then you have three main types of outputs that you can put back into the world. The first two are ones that really go to the layer one. So notices more or less like Ethereum events, but they have proof. So if you do an ERC20 transfer, for instance, inside the Cartesi machine, and you do a notice for that, basically you have a proof of the transfer. And then you have a voucher, which is a transaction that will be fulfilled in the future after the 7 days of confirmation. And finally, you have reports. They're more or less like logs. They're useful to grab information, quick information from your node, ephemeral information in general, and useful as well for debugging your application.
Does that make sense?
And from the outside, you have the add input function call from the Solidity smart contracts on layer one. So that's how you do the advanced state I was talking about before. You still need to send transactions to Ethereum because that's how you confirm that the information was really sent and is final. And then you can query all the outputs I was talking about, like notices, reports, and vouchers. You can do inspect states calls, like to check a balance. And finally, when the 7 days of confirmation is passed, you can execute any vouchers and make the transaction happen. So let's say you are trying to withdraw money from the app chain. Basically, you get a voucher saying, hey, I have a right to withdraw X amount of tokens. And then you wait for 7 days, you get this voucher and execute it. Then a ERC20 transfer will happen on the layer one, giving you back your tokens. And that is it for the overall high level overview of the technology. Now we gotta set up a little quickly for Lino. So for the setup, really, what I recommend is to have your Linux, to have a Linux and Docker installed above the version of 2010-14. And then if you don't have that ready, you can always go to our rollups examples repository and click on opening Gitpod over here. That will give you a cloud machine with access to the repository already cloned. So after you click that, it's gonna show this little screen. You continue with GitHub. It's their way of signing you up, and then you have to confirm that that GitHub Gitpod will be able to access your information in Gitpod. After you authorize, you get a VS Code online with everything that you need to get started. That's it for me, guys.
That was great. Thanks, Gabriel. So next we have Lino to give us a pretty in-depth overview.
Hey guys. So yeah, if you guys wanna open the Gitpod, you can follow along this hands-on session. So yeah, so the first thing you have to do is get to this Linux environment so you can follow along. And what we are going to do in this exercise, we're gonna run the ApplePython straight from the Rollups examples. And then we are going to make some changes. And then we're gonna create your own custom DApp. So yeah, the steps here is just clone the repo, build Cartesi machine, and then start the front-end echo. So just record these videos so it's easier to present. So the first thing is to you wouldn't be it wouldn't be necessary because you already have the Gitpod. So you just go to the examples. And yeah, go to the EchoPython directory. The next step is to build the image. So you should run the docker buildx command, and it will build the Cartesi machine. So it will have build the Cartesi machine containing the EchoPython code inside the Cartesi machine. And this image is used by the whole Rollups framework to run your code. And yeah, and then after you build this, you can already start the backend. So it should be simple as a Docker compose with some extra parameters. So you can start the whole infrastructure, the whole Cartesi node, Rollups framework node, using the Cartesi machine that you just built. So this starts all the servers necessary, including local hard hat chain that where we will run this example. So yeah, so this is just starting. It sometimes it's not really immediately after you start. You have to wait a little bit, and you can see that everything's already running, and you can interact with the application after you see some extra messages. Now to the front end. You will use front end. You have to install the dependencies. So from the Rollups examples directory, you go to front end echo and type yarn to install the dependencies. It can take a little while it gets all the dependencies. Shouldn't take that long in this machine. And then you can start the front end. And now you probably already have the front end running, and you can start interacting with it. So what this really does is sends the message to the hard hat local chain, and then the Rollups framework will get the the interaction and then send to the Cartesi machine running the Python backend code. And then it will give back the answer to the graphical, and then it will show on the front end. So this is just a example what you can do running straight from the rollups examples. So one thing that's very important when you are running the examples or any of the rollups framework, it creates a lot of volumes using Docker. So every time that you stop by Control-C, you have to also run an extra command to remove the containers. Otherwise, all the volumes will still be running, and they will affect the next time you start the environment. So it's the Docker, the same Docker compose that you run, but with down-v. Very important, this command. It's in a lot of problems, people that don't do this. So now we are going to change the Python a little bit, so you can see what the changes do. Also, we are going to use the front-end console, not the Echo, the front-end Echo web interface. So we can check out other. We can be more free in interacting with the application. So you go to the rollups examples. Then we are just going to the SQLite example to import these helper functions, the X to string and string to X. One thing it's important to note that every interaction when you every time that you are sending comments to the rollups contract and getting the information from the rollups contract, you have to convert to X and decode from X. That's why I'm getting these functions here. So we open the Apple Python and just paste these functions. Also, we are just going to change a little bit the payload. So we are not just going to shout the Apple, the exact same text. We are going to change a little bit. So the new payload will be the same payload that we had, and we'll just add a little string. Obviously, that you can do whatever you want here. It's just a quick example of how you can change a little bit and play with the examples. One thing that's very important was on the last bit of this video here, that you have to convert the string so we decoded the payload from hex to string and then from string to hex again. So then we can send the result to the ropes framework as well. So then we have to rebuild the Docker machine containing the new code. So yeah, so just to run the same example. So I just copying the same comment. You see that it builds, it just runs the same comments, and this starts the Cartesi machine with the code, and when it's ready, it just stops. And then you can start with the Docker Composer. And we'll have the new code back and running. Well, now we'll test with the front end. See how we go. So we go to the front-end console. We have to rebuild the packages, and we have to build some dependencies. So we have to run these two commands. And then we can start interacting with the application. So we can send an input. So you can tell which payload that you want. So this just says that the interaction was successful. We don't have the result yet. I'm going to send another input. I'm going to list the notices that were sent. So no notices yet. You have to wait a little bit so the Cartesi machine answers. So now we have the result. So you can see that the cave echoes the hello payload. So this was just running the Echo Python and doing some changes. Now we're going to create our custom DApp to run your own code. Also show how to use the host mode. We have a template in these rollups examples. So you go to the custom DApps directory, and you run the create DApp script. So this will create the DApp that I created, and then I'll copy the front-end console inside the custom DApp, so I can interact with the application directly from inside my directory of the application. We'll just go back to the projects page, and then I'll copy my DApp to here, so I don't need the rest of the dependencies inside the rollups examples. So now I'm going to edit my DApp. So it's several steps. We'll create the database, insert the input on this database on each and advance. So the first step is to import the SQLite 3. We'll create a connection to the SQLite database. Now we will initialize the database with a standard table that will store all the messages we're receiving from the front end. It's just a simple table, but we'll see. It's just a normal database, as Gabriel said on the last part. So it will store the payload that we are receiving, also some metadata that we receive with the rest of the messages. The payload text, also the sender will have this metadata. The input that we're receiving, the input index, is also the epoch index. Also the timestamp that from the timestamp from the blockchain that we receive. Then we'll just call to start before the execution of the main code. Now we are going to store the data that we are receiving. Just create a insert function. So this is just an insert, so we can store all this data that we're receiving. Just copying the fields, so we insert the right fields on the table. It's just when I interact with the SQLite, we will have this. We can pass all these fields once. We won't have SQL injection problems. Now, in the handle advance, when we receive inputs from the blockchain, we'll store this data. So we'll first decode the data that we'll receive from hex to string. Then we'll get a connection with the database. Then we'll execute the insert command. Then we'll commit. Then we'll finish and we'll use the same code that's answering as an echo. And finally, just add the insert SQL to the execute command. So now all the parameters, the payload, the sender, the rest of the metadata. So the metadata and the sender. Rest of the metadata, then I'll just copy to be the input index, the epoch index, and finally timestamp. It's important to know that the timestamp that you have inside the Cartesi machine, it's not it's just it's not real. So when you use timestamps, you should always use the timestamp that you are receiving in the metadata. Now we're going to start the front end, this code on the host mode, so we can see what difference it is. So now we are going to start the same, very similar Docker compose command, but we'll use the new one of the other configuration files for the host mode. What does it blocks the interface from the Cartesi machine and starts a server that you can interact, and then you can start the Python code or any code and interact with the rollups, but without needing to have the code running inside the Cartesi machine. So it's much faster to run, to test the things, make changes on the fly. All these comments, they are in the rollups, in the readmes. So I'm just copying this comment. So this is the interface that will connect from inside the application to the rollups framework. And now so you see that's running on my machine here. Let's interact with the application. Just go to the front-end console that I copied. Install the dependencies. Build some extra files. And send the inputs. see, we'll send the input and check the result on the front end, on the backend that's running on my computer. So go to the safety confirmation. So we will. Oh, so what happened? We have an error here. So I can see that I had an error. I got something I missed. I passed the wrong number of arguments to the function, to SQLite execute function. Let's fix it. So you just go back to the code, and the thing is that I passed all the arguments, and then I have to. It's really a tuple that I have to send. So just fix it. Stop the code that's running on my computer and start again. So, yeah. Just the finalization that I'm going to test. Just forward the video. So yeah, just start the backend code again. Change to the front end. Send the input again. I can see that everything is gonna work. So yeah, no errors this time. Now we are going to use the handle inspect. So it's that call that it doesn't go through the blockchain. So it's like a Ethereum call. We don't have to send to ask information, to get information from the code from your DApp without going through the blockchain. Just a way to query the things. So we're going to edit the inspect. We're going to add a new query. So we're selecting this table. So just add a where. So we want all the payloads that the sender some sender sent to us. So we're going to the handle inspect. We're just copying this part so the handling will be quite similar. But instead of adding nodes, we're going to add reports. Reports are these ephemeral information, and then we're going to change the payload. It should be simple as that. So we won't commit anything because we don't doing any changes, and in inspects we don't change the state of the machine, so it doesn't make any sense to commit and change anything on the database. And we're just going to change the result to a string, and then I have to convert to X. Now we're going just to check. We're restarting the backend code. We're going to use the inspect tool on the front-end console, and the payload will be the sender address. So it's the address that we have that we are sending all these transactions. So I'll just copy and set. We can see that we have all the result of the query. So that's the result. So the payload, the sender, the input index, the epoch index, and the timestamp. So have these two results in the database. So after you build your DApp, you have to build the code inside the Cartesi machine. So it's not enough just to have the code running on your host. So you have to make sure that it's running inside the Cartesi machine. So once again, you have to stop the Rollups framework, and you have to remove the containers. You shouldn't forget this. It's very important. Sometimes it has all the containers running, and it takes a little while to run the down-tashv command to remove the containers in volumes. And we can generate the Cartesi machine using the Docker buildx big comment. Starting the application, and after build, you can start the backend, the Rollups framework using the Cartesi machine. So we don't use the Docker Compose host YAML file anymore. So we'll just start the code from inside the Cartesi machine. Finally, we're going to test, see if it's still running, don't have any errors. And if it's all good, your DApp's ready to be deployed. Sending the rule inputs. We'll see if everything's it's running, if you have all the results that we expected. So run the inspect. I have everything here. Now we check that everything's up and running. So this is the whole process of building a custom DApp using Python, obviously. But yeah, well, so what we didn't test in this quick presentation here. So the next thing that you should do is deploy the contract on testnet. So after you do this, any node, Cartesi node running can get the DApp and can test take all the inputs and run, and see that everything's is running. That's running. And then the next thing would be to deploy this DApp on the Cartesi infrastructure. So you will just interact with the DApp and using the front ends or any front end that you build, and so be effectively up and running on the testnet. So obviously it was a Python template, but you can change the bits inside this custom DApp to all the other language using the Rollups examples, other projects inside. Also, you can add other libraries and add complex logic to that. And there's also assets manipulation, like receiving some ERC20 and ERC71, and also add vouchers to interact with other contracts and also to withdraw assets from the debt. And then you can check all the computational power that you can do with these DApps. And also the next steps is to join the Cartesi community and build the DApps, the next steps. Okay. So guys, that was the quick presentation on how to build a Python custom example. So I can send to you back, Zach.
Thanks, Lino. That was great. All right, so now that we've done the intro to Cartesi and a quick little workshop showing how the Echo Python works, does anyone have any questions about our technology or what's possible on it? Well, sweet. That means we did a great job. If you have any ideas that you'd kind of want to build on Cartesi, we are currently doing an innovate-a-thon in our Discord where you can write down your different ideas and get feedback from the Cartesi team. It's actually really cool. I think that there's someone in the call that actually has something. Schwarzu? Is that how you pronounce it?
Yes, I have a question.
Go for it.
Do we have the code or the GitHub of the cave page thing? I want to do something like that with JavaScript.
So the Apple Cave code, you mean?
Yes.
Yeah, it's everything from the rollups examples. It's the custom my DApp that I created that it's not there, but it's very simple. You can follow along the video that we send and you'll be able to do it.
Okay, thanks.
Yeah, really great videos, Lino. I'm excited to see this presentation on YouTube and rewatch it. It's kind of cool to see one of the Echo Python apps being built in real life. All right, do we have any more questions? Guess not. Do we have any ideas for anyone that's attending ETH Denver that wants to build and hack on Cartesi? Okay.
Come on, people, don't be shy. If you have any last questions or anything, there are so many people here.
Swarzu, I was wondering if I could call you out and ask about your idea that's on the Innovate-a-thon. Can you give us a brief overview of that?
Sure. Now or in another call?
Now, if that's okay.
Okay.
Decentralized game development decision. Sounds pretty cool.
Yes, I was thinking about build a community. I mean, first have the idea of a game, then build a community where the community itself could take decisions of all the involved parts in the game. It's maybe a little topic, but
No, it's pretty cool. It gives people kind of the ability to vote on different game development.
yes, I don't know how to think the part where the developers take part. I mean, if the community votes an idea, how can it be built? It's like um, I think that's because I don't know a lot about AI, but I think that with an AI taking the responsibility to I don't know how to explain it, but the developer that can do that development, you have to know him. You have to know how he work, and that the
Sounds really
difficult
cool.
part.
It's a unique way to kind of decentralize game voting.
Yes.
I like it.
Okay.
Well, I think that wraps up our call. Do we have any last questions before we end it? Blockchain, Lino, Nico, Paul. Any questions?
I think from you all good, guys, with very great content. Thank you.
I'm glad that you liked the presentation, Nico. Was there anything that stood out for you?
Well, yeah, I really liked the second part, especially the hands-on, because, I tried out the first two tutorials. They're great, but I'm now having a deeper dive into the building your own one. So I'll definitely rewatch that one and try something for myself.
I bet you're looking forward to these being on YouTube. I know I am.
Hey, I have a question here.
Sure thing.
We are like wondering what is the purpose of the HTTP requests and how do they work basically on the Cartesi ecosystem, obviously.
Can I take this one, Lila? Or can I? Okay, so you have this machine, right? And it's a black box of sorts. You still need to be able to communicate with that. And if it is not producing anything that will change the status of things on layer 1, then we will not be producing any of these notices or vouchers that I was talking about, right? However, you still need to know what's going on inside of the machine with the code that you produced for it. And in order to do that, we created these inspect calls, like we call them, which they are like GET calls from the REST APIs. Basically, you can query anything inside a machine as long as you coded the reply for it. So let's say you want to know a balance or how many games you won, or even what is the status of many tables across of a game. Anything really that you need to populate an UI or to give feedback for your user, that would be an HTTP inspect call. So you would basically be creating this internal API as well to reply back whatever information you think is necessary for your DApp. Does it make sense?
Yeah, it makes for sure. It's perfect.
Yeah, the only difference you need to keep in mind is you're not changing anything in the Cartesi machine when you're replying to inspect calls. So you cannot, for instance, keep a counter of how many inspect calls you received, because the machine is always being reverted back to the initial state. You cannot change anything there. You can just read and reply back information.
Perfect. Thank you, Gabriel.
You're welcome, man.
All right. Any last questions before we wrap up the call? All right, then we're going to wrap up the call. Thank you, everybody, for attending. Thank you, Gabriel and Lino, for presenting. Those presentations were really cool. Thank you, Swerzu, for talking about your idea. Thank you, Nico, for chipping in. Thank you, Polarex, for tuning in as well. This was great, guys. Let's do it again.